Jaber Shabanian, and the title of his thesis is Hydrodynamics of Gas-Solid Fluidized Bed at High Temperature in the Presence of Interparticle Forces. And his thesis advisor is Jamal Shawki.
Hello. I'm pretty sure that all of you have seen how water boils in a kettle. Pockets of steam or gas form in a kettle and move upward to the surface and then erupt at the surface. This causes water circulation inside the kettle. Theoretically, the same phenomena can happen in a gas-solid fluidized bed. Why? The artificial continuous phase is made by solid particles. This system has plenty of application in chemical industries, and most of them are used as chemical reactors. One of the basic but very important parameters regarding this system is how gas and solid are in contact together inside the bed. This is actually called hydrodynamics of gas-solid fluidized bed, or bed hydrodynamics. This is in fact defined by the magnitude of different forces acting on each single particle inside the bed. All of them can be categorized as hydrodynamic forces and interparticle forces. The first one comes due to the action of gravity and fluidizing gas, and the second one is due to the mutual action between particles. Since most of these reactors are operating at high temperature, it's very important to know how gas-solid contact change when we increase the operating temperature. The first thing that comes to our mind, and normally considered by researchers, is that bed hydrodynamics can change due to the variation of hydrodynamic forces, which is caused by the variation of gas properties. However, this is not the whole story, and we might have some modification in the solid phase, which can be translated into the variation of interparticle forces. They can change the hydrodynamics of the bed too, like producing large agglomerates of primary particles inside the bed at high temperature due to the presence of interparticle forces. My PhD aimed to demonstrate the importance of interparticle forces at high temperature and understand how they can change the bed behavior. So we know what we want to do, but the question is that how we want to do. Due to some limitations that we have at high temperature, we had to divide our project into two sub-projects. In the first phase, we tried to reproduce the same situation that we have at high temperature, but this time at low temperature, and in parallel, we did some experimental work at high temperature. So for the first phase, we used a novel technique that we recently developed in our group called polymer coating approach. In this approach, we covered the base particle with a specific polymer material and then subjected them into different temperatures. You can see that the behavior of coated particle completely changed from only 27 degrees C to 43 degrees C. So with all the experimental work and simulation work that I did, we could have very good understanding about the effect of interparticle forces on bed hydrodynamics, when they can be beneficial in order to improve the performance of the reactor, and also we could understand how we can identify and prevent the fluidization phenomena which is caused by the presence of strong interparticle forces. All of them means that we are providing very valuable information to chemical industry in order to increase their income. I hope you enjoyed my presentation. Thanks.